Hey folks, it's Rob Flux here with another Sunday session, and today we're continuing on our series when we're talking about prefabrication, and one of the many technologies in the prefabrication pathway is a thing called additive technologies. However, you may know it as 3D printing. And so in order to talk all about 3D printing, we've got Nick Holden from Contour 3D, who's going to tell us all about how the technology works and his company in particular. Mate, welcome aboard, Nick.
Thanks for having me, Rob.
Mate, we went out to, I guess, your warehouse the other day. Well, the factory is probably the better word for it, where you actually manufacture the machines. It was quite impressive to actually look. And during this interview, while you and I are talking, we're going to be playing some of the footage over the top just so people can actually visualize this, because it's very hard in an interview style process. But firstly, why don't we start with, who is Contour 3D? Who is Nick? How did you come about, I guess, going down this pathway, mate?
Yep. Yeah, look, I suppose I started off my early life as an automotive mechanic, actually, out of school. And then I spent a lot of time overseas in Europe. I sort of having in my 20s, doing what 20-year-olds should do. And I used to come back here and build machines and start my mechanical engineering sort of degree. And then when I eventually got back after 4 years overseas, part-time, I was in Europe for 9 months, back here for 3 months. So it was really good. I didn't have a summer. I didn't have a winter, I should say, for a very long time. So I started modular walls. I bought a house to renovate, and the council wouldn't let me put a brick wall up there. So I started the company Modular Walls, which is in the composite industry. And then I've probably been doing that for 20 Geez, it makes you sound old now. 20 years.
So that's what other people would refer to as panelized construction.
Correct.
Yeah. So you've been doing that side of the world for a while.
Absolutely. So that was, and Modular Walls specializes in very high-end noise walls, fencing, that type of thing. So, but in a composite sense. So yeah, very familiar with the manufacturing side of things, and obviously that side of the business. And originally, I started Contour 3D during COVID. Modular got locked down for a while, and I got bored, I suppose, at home. I couldn't watch any more Netflix. So I went into the factory. I had another factory at the end of the road, fortunately, so it wasn't sort of doing much. And I got one of my mechatronics guys in as well, and we sort of kicked that off, really. And where it came from, actually, I originally saw it, and I originally thought, wow, that'd be a good idea to print noise wall panels for modular. But then as sort of the housing sort of things started getting really dire, I suppose, it was probably dire before that. But, I thought, look, I really want to make a difference, do something, without the bank of mum and dad. Kids can't really afford, to leave school anymore and buy a house. That's a pretty sad state of affairs that we find ourselves in. So
absolutely. I guess getting more houses out in a faster timeline, a range of technology is really the goal and the message we're trying to push here. But additive technologies works a little bit differently to some of the others. And so now many people will be used to looking at 3D printing machines in, I guess, the plastic and composite sense, but you can actually 3D print all sorts of materials. You can do steel and stainless steel, and concrete is just one of those. I guess, what made you pick specifically this particular material, and why specifically, printing houses?
That's a good question. And I used to do a lot of plastic 3D printing from an R&D sense and a rapid prototyping sense. So I was familiar with the desktop 3D printing sort of stuff. I was quite proficient at that. And I suppose we roundabout, and a couple of years on, we've sort of manufactured a very large desktop printer that can print houses. So look, and I suppose if you're looking at that type of technology, to print houses, you're limited in your selection at the moment. Like, you can't print a plastic house, really. There's other biomaterials, I suppose, but I took the concrete route because it's obviously it's a very efficient material in that regard, and it's a single source of material for us because we're printing the inside and the outside walls in one go. And we've got some material scientists on board that are full time with Contour, and we developed that. Concrete's got a bad stigma, right, with Portland cement, really. So that's desperately sort of tried to get away from that and sort of push ourselves into the sustainable category. At the moment, we're at about 40% recycled materials. We're down to about 12% Portland cement only. And we are sort of pushing that envelope to get that right down to nothing. But to answer your question, I suppose it's robust. It was, I originally saw the technology. I didn't know anyone else that was sort of doing it at the time in Australia. Uh, and I saw the technology on YouTube from Russia, maybe 6 months before. So the Russians were sort of playing around with it, and I got to say, it's been hard. It's been the hardest thing I've ever done. My other business, 4 warehouses, 80 staff, but this has been hard.
But rewarding, no doubt, along the way.
I'll let you know. Okay. I'm checking in 12 months. No,
Yeah.
it is. I mean, I'm working harder now than I ever have, and I do some 100-hour weeks, some weeks, but I love it.
Yeah.
It's challenging. But my dad always used to say to me, just because you can doesn't mean to say you should. And I fall into that category. So
That's a
originally,
phrase I use a lot to our community mates. So
yeah,
yeah, in this instance, not only could you, but you have that's out there, and you've actually got real live products and those sorts of things. And we're going to talk about some of those really well.
yeah,
So I think your perseverance is paying off, mate. So I
no,
guess
it's
yeah.
been good. But I just say, just on that front, there was no instruction book. On the back of that, just because you can, shouldn't be say you should. I actually rang around the world to see, can I buy the technology? And yeah, I mean, some guys were doing it in Europe, but they were using sort of robotic arms, like the ones that manufacture cars on, and it wasn't sort of on the scale that I was looking for at that time. So we dove in head first, tested the water with both feet as usual, and started small, and eventually we got it working. The materials, the machinery, the software, the code, it was hard.
Yeah, well, there's a number of different challenges. There's also a number of different opportunities.
Yep.
We might kind of start with the
Yep.
opportunities first. So concrete, high thermal mass. So that means that it takes a long time to heat up and a long time to cool down. So
Yep.
structurally very, very strong.
Yep.
It's been used in housing for I think since Jesus was a boy. So it's been around for a while, but not in this particular format. So in
No.
trying to print it, that creates a whole range of challenges that you wouldn't have in a precast type arrangement, because you're kind of building a layer and then putting another layer on top, and you're kind of
Yep.
needing the layer below it to be have enough structural integrity to then take the
Of
weight
course.
above of the next one going up.
Yep.
So how do you deal with something like that? What's the I guess the challenge that you need to deal with there?
Yep.
And then
Good
talk about
question.
your magic solution that helps you get there.
Yeah. Yeah. The material scientists. It was very challenging, and there's a lot going on. So you got this 10,000 problems, with 100,000 answers. So you just got to sort of sift amongst it. But how we got over that eventually, we had a base mix, I suppose, that we worked on, which was getting us by, and it was good. And I should probably clarify at this point, we're a mortar, not a concrete. So we have aggregates of 5 millimeters or less. And I'd ask people to think about it not as a concrete or even a mortar. It's that highly modified. It's special. We've got some elasticity in it. We've got a lot going on. The rheology and the thixotropy of it. I learned, increased my
Big words.
vocabulary in the last few years. But we had loads of walls fall over, right? Loads. Collapse under plastic collapse, or just off it goes. I spent many a time on a shovel putting it in the concrete bin, and they send it off, they crush it back up and sell it back to us as crusher dust. So, yeah. But yeah, and I mean, I don't know, through good luck or good measure, or we just don't give up. We've got world-class layer quality. It is just really fantastic what we landed on. But it has been, honestly, what's that, 2020, 2019? I'd say I started in 2019, and then I didn't really do much until 2020. And I put one person on, and 2021 put two, and then now we're a team of 15 down at Contour. But yeah, to get back to your question, how do we keep it? And now we can build a wall 4 meters tall, 50 mil thick. And sure, we link the two together with reinforcement, but it's pretty cool. Look, there's a combination. Are you printing outside? Are you printing inside? What's the lap time? What's the, and we do have the ability to obviously vary the mix, the speed of the mix. So, where I am now at the duplex in Woolooware, that probably had a 12-minute lap. It was a long, big print, so, and it's sort of a tortoise.
When we're talking about a lap, let's just use some of the
Yep,
terminology. We're talking about how long it actually takes to print one layer and come
yep,
back to the start, then add
correct,
to the next layer, right? So if you're
correct.
printing a very, very big wall,
Yep,
the lap is going to take a while.
yep.
If you're printing a very, very small wall, then the lap is going to be much quicker. So
And that's a problem. And then the other's a problem. You know, you got cold joints on one side, although there is a huge window, you know, of that. But the short laps, if you just got a standard mix, you know, just one mix suits all, which we don't. That's when you get stuff collapsing, right? You can't do
yeah.
a short lap.
So
But
the challenges that I see it, and I'm coming from a lay
yep,
perspective,
yep,
there's I guess the speed it comes out of the
yep,
nozzle. There's the volume that comes out of the nozzle with
yep,
which then creates weight.
yep.
There's the viscosity of the material. So is it going to actually pour over and not maintain its
The
form?
thixotropy.
So what was the word?
Thixotropy and rheology. So thixotropy is like that. I always say to people, it's like that. You know, you used to make Play-Doh for your kids, and it's sort of squishy, but then you can smack it, you know, and it's hard. It's
Yeah.
sort of there's a bit of that going on.
Yeah. Then there's how long until it dries,
Yep.
so that when you put the next layer on,
Yep.
that you said no cold joints.
Sure.
Then you've got, well, if you pour the next layer on too quickly,
Yep.
you haven't actually got any structural integrity on the layer below to actually take the weight of the
Yeah.
layer above. So there's a lot of science that goes in. You called it material science.
Huge amounts.
From, I guess, what we discussed the other day, you're doing a whole bunch of things, I guess, from a monitoring perspective to actually understand the rate of flow, I guess the air temperature, the weather, the moisture
Yep.
content, and a whole bunch of other things. And you're kind of fine tuning it on the fly.
Yeah, and we've got it that good. It can fine tune itself now. You know, take the human out of it. But you're very right. You know, we put a lot of work into that. You know, we can measure almost everything now. We've got cameras, we've got sensors, so we're monitoring all that, and we know before we even turn up. Right, if we're printing on site, you know, we know the lap time. And just to clarify, a lap is normally 2 laps, I would say, 2 skins, because we're printing an inner wall and an outer wall. So it's sort of a continuous loop. It's, if we can, you know, it's inefficient to stop and start, which we can as well. But yeah, what was your question again?
No, it wasn't a question. It was more the fact that you're constantly monitoring and tweaking
yeah.
and adjusting.
I remember. I think I told you, I used to think concrete was a dumb industry, right? It's been around forever. You know, it's just, what do these guys do? But it's really, really technical, I suppose. And particularly in this end of the field, you know, where you're sort of carving new ground and you have to do things which concrete probably wasn't ever designed to do. So that's why we've got a lot of special, I think I called it the pixie dust the other day. I think we've got 16 additives in that. It can be as small as 0.1 of 1%, you know. And it's amazing what some of this stuff does. It's such small quantities, but I think we beat the kernel by 5 herbs and spices. So they all cost money.
Just so that everyone understands,
Yep.
you put this pixie dust into, I guess, the material in the mixer, for want of a better word, and it gives you all of those magic properties they're actually looking for with regards to, well, it's going to maintain its structural integrity, it's going to dry at the appropriate rate, it's going to maintain its form and the like. So there's a lot of, you called it material science, that actually goes into that.
Yes.
That is the secret sauce, right? That is the 11 herbs and spices in this particular instance. 16 herbs and spices. Don't go tasting it, folks. It's not yummy at all. But
I think our material scientist has it on his cornflakes for breakfast. They love that stuff.
Yeah.
They live and breathe it.
So for anyone, I guess, wanting to go down this 3D printing path, you don't just buy a machine, then go to your local concrete supplier and go, hey, I'd like to print out a house, right?
No.
It's a combination of the machine itself and also, I guess, the way that the actual mortar is actually created. You've got to use those two, I guess, together as a unit.
Yeah, you're absolutely right. I mean, the machine will probably pump anything you want it to, barring large aggregates. But yeah, it's how it puts it down and what its form is, you know, and how it holds its shape. And you're right. And what you normally find happening, actually, is it's not where, if you're doing a too fast a lap, right? It's not the laps sort of 3 underneath it. It's probably the bottom one. You can start to see the bottom one go. And as soon as that happens, you're like, And we don't have walls collapse anymore, fortunately. But yeah, that's where you can sort of see it. You're like, oh, it just goes. It's like dominoes, and it just it takes off.
Yeah, well,
It's a horrible sound.
the learning phase of that is now gone. But anyone taking up a machine has to learn from the
Correct.
lessons past so that they don't do the
Yep.
same thing. But
And we've
uh,
taken all the we've taken all that out. So yeah, you're right. We are selling machinery and printers. But and that's probably not a bad story actually. So we originally were using Siemens software and Siemens control systems, and they were so expensive, and you couldn't do anything with them. They wouldn't let you in the back end. They had 9-month lead time. I was like, that's not a lead time, man. That's a go and get stuffed. So I put on 3 software engineers in the end, and we built all our own gear. So we've got our control systems and all the rest. So now our architecture, it's designed to accommodate all these different things that we're doing and measuring and things. So we've tried to dumb it down, and I haven't used the machine for a long time in that regard, but I can pick it up and, it's simplistic. It's not code based. It's, and it sort of works it out for itself. Cause you're right. We've got weather stations. We can have lasers. It's not a laser, but it's like a LiDAR sort of measuring the layer width and sort of self-correction going on. So there's a hell of a lot happening, to make it look so simple and so nice and smooth.
yeah, now from a look and feel
Mm.
perspective, I guess if anyone wants to visualize this, all they need to do is look behind you. There's a wall
Yeah.
immediately behind you. You're living inside, I guess, one of your own products.
Yep.
The expression "got to eat your own dog food" sort of thing. And I guess, just for everyone out there,
Yep.
Nick was kind enough to actually take me inside the home the other day, and it's amazing, mate. And genuinely,
Mm,
I guess it's hard to describe the warmth that you feel by walking inside the property. It doesn't have
I agree.
that coldness of what you would anticipate I guess a structure like that to have.
Yeah.
Now,
You
in
can say
your
you can
instance,
say it, a concrete house.
yeah. Well,
So-
you've told me specifically it's not concrete, so I'm not going to use
but
that word.
only you wanted to say it. So,
Yeah. But because of I guess those contours are a natural part of what it does, but that's not necessarily to everybody's taste. And so you've been
no.
working on ways to actually go, well, what can we do to actually smooth the wall out so that
Yep.
you can actually have a more traditional look and feel? Tell us a little bit about the journey that sits behind that.
Yeah, so it's something we started a while ago, but then obviously we got busy, right? So as you do. But yeah, we revisited that probably a month ago, and we have now got a really, really efficient scraping mechanism and smoothing mechanism going on. So we can choose to turn that on and off for different walls, particularly if you want your whole house that way, that's fine. It's just like a rendered wall inside the house, I suppose. But if you still want the, I call it the corduroy effect, so it's better than layers, I think. It sounds a bit more trendy, but if you want that, but if you're tiling in the bathroom, you don't want to be tiling over this stuff, which is fine to tile over, and I've done it. But if you've got one layer that's sticking out a couple of millimeters more than the other, the tiler has a heart attack, right? Oh, we got to render the wall, sure, whatever.
Yeah,
So
well, I guess basically this scraping layer is what it's doing is it's taking those little
yeah,
bulges that you're actually
correct.
getting
Yeah,
and smoothing those out. So
yep,
blending, I guess, the top layer into the layer below, and so it kind
it
of
does.
smooths the finish out.
We sort of go 2.5 layers down by the time we get up high enough to do that. And it's not so simple again as it's just a scraper. So we actually go from a circular nozzle to a rectangular nozzle or a square nozzle. Then it's got a scraper on the left, scraper on the right, and they're on linear actuators that we can choose how far they go up and down. So there's a lot going on in the code there, because then we've got to tell it to turn the corner, do this, turn this one off, turn that one on. But you've got to make it super simple as well. All right. So I've been working on for a good couple of weeks now the upgraded slicer, which I think I showed you.
Yeah, and the outcome looks really, really good. Now,
Yep.
there's a small amount of finishing work that needs to occur, but it's relatively minor in the scheme of things. I guess anyone who's dealt with old school rendering solutions, you'll know that there's a thing called bagging. It's kind of very similar to that, where you
Mhm.
kind of just go over it at the end and you kind of clean up the little edges, for want of a better word.
Yeah, I suppose I reckon we're 95% of the way there. We've got them down, and that was probably only the second time we've ran this new, or first time, I think, the ones that you saw, that we've ran this new print head. So we'll absolutely get it I mean, we'll get it perfect, you know what I mean? But at the moment, you're right. If you just run over it in half an hour, you know, when it's sort of tacked off, I suppose, with a sponge or a flat trowel, plastic trowel, it'll be actually smoother than your renderer, you know, because this thing's CNC. It doesn't have an option to not be on track.
Yeah, look, the word CNC, a lot of people hear that, but they actually don't know what CNC is.
Yeah. Ha, that
But
put me on the spot. Computer numerically controlled.
yes, so effectively, it's basically, I guess, the three-dimensional axes that the
Yep.
machine is actually operating on.
Yep.
It understands, I guess, the speed, the angle, the depth, the height, and all of those elements,
Yep.
and is actually controlling that in a very particular way to say we're going to lay out this material in a way that structurally builds upon itself.
Yep. Yeah, correct. And that's why, back to your material question, on that timing, yes, we've sort of settled on two mixes. We've got a house mix, you know, which will go anywhere between sort of 4 minutes and sort of 16 minutes, depending on the weather, obviously, if you're inside, outside. And then a super fast mix, you know, where we can print columns and whatever else. But so we've got we've got the one print head there with these scrapers on it. We've got a standard print head, and we also do have, and I think I showed you a picture of it, accelerated print head where we're mixing accelerant right at the head, which we don't do a lot of, to be honest. But when we're doing ornate columns and you've literally got a 4-second lap time, you know, we're taking water out and pumping accelerant in, and literally there's steam coming off this thing, you know. But you can just continue to build a column, you know, with a 4-second lap time. It's pretty amazing.
And when we say accelerant, we're accelerating the dry time and speeding it up
Correct.
to.
So by the time it's done one lap, you know, by the time it's done, say 2 or 3 laps, that, you know, the third one down is hard. You know, we're pumping. We typically use the Sika sort of concrete liquid accelerants that we're pumping in. But again, there's a hell of a lot going on, you know, in the dosing, the things, pulling water out, doing this, doing that, and so it's yeah, but it's easy, you know. Once we make it look easy now, I think, or the guys do.
Yeah, well, and look, from a look and feel
Yep.
perspective, um, it feels it has a very specific look to it. So it's
Yep.
one of those things that I think people are going to either love or hate.
Sure.
This that smoothing, I guess, process that you've got is
Yep.
going to bring it back to. Well, for those of you who don't like that look and feel,
Sure.
you can kind of disguise that.
Yeah.
But then for those who love it, you've got then the layer, I guess, the opportunity to actually build patterns into it and actually deliberately emphasize
Yep.
the technology and do all sorts of looks that look like a wicker basket
Sure.
or a pattern, or like how does that little process work? And you effectively, I've seen you design logos into walls and all sorts of things.
Yeah, we did that recently for a commercial cafe for Movac. Yeah, we put the estate's logo on the wall for them, which was pretty cool. It's in the code, you know what I mean? And that's what we're trying to dumb down again with this new software system, because to put a parametric pattern into essentially, so we draw the house in 3D, first of all, and you can do your corners and your whatever you want to do, you know, and sort of funky shapes. And the wall behind me, it's a corrugated wall. Height down this end, by the time it gets whatever it is, 15, 16 meters up to the front door, we sort of smoothed it out. And as you've seen, I'm sure you've got images of it, we've got sort of cantilevered walls as well, and sort of walls with arcs in, and it just stuff that you couldn't do with normal construction, or not way cost effectively. But to put those patterns in, these are just 3D drawing. But to put those parametric patterns in, and the patterns, like we call it rope weave or basket weave or whatever, you know, you can do. At the moment, you draw it in 3D, you sort of import it into a software system, which is a plugin called Grasshopper, and that is complicated, really, really complicated. It's like one of those wire diagrams where you're pulling things and you don't know where the veins are going, and it's doing all sorts of stuff. And it's the type of thing, once you do it once, unless you save the file, you could probably never replicate it. But I don't know if I showed you that element of the new software system where now I just want it done, you know. I want to say, I used to use Grasshopper 3 or 4 years ago. I can't use it now, you know. It's just that complicated. It's not a job for anyone apart
But
from
you're
the
starting
CNC.
to build that into your code systems to be able to put
We
those
have, so you can
patterns
just draw a selection on the wall, you know, where you want it. It'll sort of snap to the points, and then you can select one of the sort of 50 that's in the library, really, and then it just does it. And It's funny to watch the printer when it's doing it, because it's doing it so gradually, and it might be only moving in 5 to 10 millimeters at a time, and it just looks like the machine's going bonkers, right? But you stand back after 10 minutes, you can sort of see it starting to come out of the wall.
Yeah, and genuinely, it's you can make some really fantastic artistic feature walls out of that,
100%.
and really emphasize the technology rather than try
Yep.
to disguise the technology, which a lot of other people are actually doing.
Yep.
Which kind of is there's a dichotomy here where
Yep.
you're using what is a perceived, I guess, cheap material,
Yep.
but you're creating outcomes that are very, very architecturally difficult to use with any other technology. Now, if I go to any builder and say, "Hey, I'd like to do a curved wall," he kind of reaches into his a calculator and goes, "Right, that's going to cost you that,"
I'll
right?
put a zero on the end.
Well, sometimes a couple, mate. But I guess those curves are a natural part of what this
Mm,
technology does. You can actually, rather than hide from it, you can
sure.
actually lean into it and go, right, let's go for very architectural look and feel type
Yeah,
outcomes.
as we have here, there's no sharp corners, and we can almost do a 90-degree corner, as we were discussing the other day. And if we modified the scraping head with it, we could do an absolute 90. But it's been done, so I'm loving it. So we printed the duplex here, and then we sold one side off, and this was just sitting here as a display house. So just over Christmas, I thought, I'm going to move in, and I'm really glad I did. Don't get bored of it. And as you said, it's got polished concrete floors, concrete walls, plasterboard ceilings, but I love it. There's no artwork on the wall, as you sort of pointed out as well. It's its own artwork.
I said it feels warm.
Mm,
And what I mean by that, there's I guess the texture in the wall naturally dissipates sound so that when you
yes.
go in there, you're not getting the echo that you would anticipate in a concrete
No,
in a in a concrete room. Very much absorbs the sound and it's almost silent. Like it is.
it's good. Yeah, and that was an unexpected effect. I remember when we did the first one, I was like, wow, this place is eerie. So, yeah, you're right. It's refracting off off the sort of the corduroy, I suppose.
Yeah, but in a
Mm.
good way, folks. It's not in a hey, you're in a padded wall kind of scenario, and you're going to go mad.
I haven't had a rave
But
party in here yet.
you, I guess, on the display home that you've actually
Yep.
got there, you've not just built the house itself out of it, but you've
Yep.
gone all the way into printing your garden beds. You've printed a
Yep.
holder for your
The
firewood
firewood. Yeah.
and a whole bunch of other things like that. And you've really leaned into the technology. What are some of the use cases other than printing a house? What are some
Yep.
of the other use cases that I guess
Going for.
you're that you've already delivered?
Sure.
Because I want people to kind of understand that once you are not limited to the design parameters,
Yep.
you can pretty much roll out almost anything. But
Absolutely.
don't limit yourself.
No, no. And I fell into that trap initially, which we had to really, because we're doing everything, doing flower pots for this guy, chairs for this, council, picnic benches and things, and sort of civil components and this and that. And then we'd go and print a house, and then so. But nowadays, so we're printing houses. We're printing a hell of a lot in the factory now with our sort of prefab system that's really very close and coming. But we've found the civil market is a very good one in that regard. Anywhere you'd normally use precast, I suppose, because the Transport for New South Wales in particular, they're sort of, I think they think the precast are holding them over a barrel, which I'm sure they are. Where we can come along. Let's take a drainage pit, for example, or a custom culvert, not a culvert, one of those big water tanks or pits that they put in the ground. When they do a development, and I've got a friend that works for Lend-Lease, they were doing a huge development, and they had, say, loads of these things. They were lined up, 20 of these pits. But then all of a sudden there's something in the ground, and they needed 3 custom pits. So they go to the precaster and he goes, yeah, mate, no problem. It's going to be 2 weeks to make the mold. Got to let it pour it, got to let it dry. You can pick it up in. The guy's like, man, I need it yesterday. It's costing me like $1 million a week. Where on the flip side of things, we just go, send us the CAD file. We'll put it in the system, code it in half an hour if we wanted to, and then send it back for approval. And something like that might take us a couple of hours to print. But because we sort of achieved 60 MPa, 56 to 60 MPa after 28 days, but we get 22 MPa after 24 hours, then next day's 30 odd. So you can literally pick it up after 2 days, put
So
it on the back
we
of a
might
truck
just because a few people out there won't know what MPA
and
is, but basically it's the strength
the
of the concrete.
strength. So, and to put it in some perspective, I mean, normal concrete slabs that you're standing on, are probably 20 MPa, maybe up to 30. So we're sort of double the strength of normal concrete essentially, but we've got double the strength, but with a lot less cement, and we've got some of that elasticity in it as well. So, and that's where the material science comes into it.
So, and as a result of that, you need, I guess, way less rebar and structural reinforcing and that sort of thing, but you still do need some to do that. So kind of as you're laying the wall, you're kind of building that reinforcing and ribbing into it. How does that kind of play out? What does that look like as it's kind of printing out?
Yep. So because so we're printing typically a 50 millimeter layer for a house, and then we print 2 of them, obviously, and leave a cavity. So every 20 layers, so say 400 mil, and the machine will ping us when it's time. We do lay, and we don't use steel. We use sort of typically 6 to 8 millimeter fiberglass reinforcement. And believe it or not, it does have 4 times the strength of steel in certain directions. So we do lay that longitudinally, I suppose, and then we print over the top of that on the layers. And then the next layer, we'll put crossbars in. So if we've got a 50 mil layer, and a 100 mil cavity, or whatever that is, we'll put a bar across there. And obviously it doesn't stick out, and we print over the top. So it gives you that composite action of the walls as well. So we're not just relying on a single skin. We've got the footprint of a double skin, and then we've got a cavity for services, for plumbing, electrics, insulation.
Yeah, so I guess the front skin is holding up the back skin, and the back skin is holding up the front skin, and because they're kind of tied to each other, so to speak. Yeah,
Definitely. Yep.
yeah. So
And brickies, and not brickies, the Antichrist. No, I wish there were brickies around. It's not around, but plumbers and electricians, there's no noggins to battle with. So it's so easy to wire and to plumb.
yeah. So now, with regards to that, from a wiring and a plumbing, and I guess even putting things like windows and that sort of thing in, you kind of need to plan ahead for this, but the machine can basically print the hole.
It does. Yeah. And that's, so it'll leave the holes for the windows, or we do something in the doors. And so, and it's absolute, right? Because it's a digital model. It's not relying on a brickie or a carpenter with a bent level. It's, as long as you level the machine correctly, which it knows if it is or not. But even down to the point where PowerPoints and so forth, so the machine can come along and say, I'm just looking here, say the PowerPoint's over 4 layers. So in the middle of the middle layer, it can just put a wobble. So you cannot miss. You can't put a PowerPoint in the wrong spot there, as opposed to over the other side. You can put markers in there.
It's 10 hours.
I think your Siri was talking to you then.
No, I got this. Sorry, let's start again. Yeah, I got this. I don't know how to turn that off. It's got an hour marker. It goes 9 o'clock, 10 o'clock. And I'm like,
that's okay. Well, it's just keeping you on track. It's all good.
Yep.
That's why you're doing the 100 hours a week, mate. It's kind of reminding you that you haven't done enough. So just to, I guess to clarify that it's, I guess, doing the printing and the indents where the PowerPoints are going to go. Yep. So I guess knocking that out is really easy. Hollow wall behind, so running cables, and the cable management doesn't have any of those noggins to play with. I guess the actual windows and doorways, it can clearly change direction when it gets to where the window's going to go. But eventually it's getting to the point where it's going to go over the top of the vacant empty space. So how are we dealing with that?
Yeah, and we do that as well. But we've done a few different methodologies because we recycle the concrete. If it's faster and more economical, we can just print it. We'll make sure we put the reinforcement in the correct spots on the lintel, and then we'll just cut the window out when it's sort of damp, I suppose, and push it out later and recycle the concrete. Or we do have a very cool stop-start function where we can come to the edge, either stop, then transition to the next layer, or we sort of continue it on a curve, I suppose. We'll come along, and then where the window is, we'll come back and head the other direction. So it's a couple of different methodologies, but you're right, we do typically use a lintel on top. Not all the time. We may choose to reinforce, the layers on top quite heavily. So we're forming like a concrete beam, essentially.
Yeah, and that's something that the structural engineer is actually working out
Yep.
So the architect's coming up with I guess the grand plan of what it's going to look like, and the structural engineers going, right, this is what we need to do with regards to, in order to get
Yep.
those
For
strengths.
sure.
What is the print speed I need to go at, and how how are we going to navigate these little obstacles? And that's I guess where the second layer of secret sauce is
Yep.
is knowing how to actually apply the technology.
Yeah, I mean, we got some very good guides now, and the system itself will, once you put it into this a software system and you put the house in, so you put all the site parameters and everything, it'll go, it's not going to work in that configuration or that lap time. So you can change directions or change your print plan. So we've just tried to take all that, thought out of it, I suppose, in regards to having to be overly skilled, just moderately skilled.
So, excuse me for 2
Yeah.
seconds. Sorry, I'm going to die.
No,
I guess it's probably appropriate to point out that your company, Contour 3D,
Yep.
manufactures the machine. You are not yourself the builders. And so I guess anyone who's thinking of wanting to take on this from a technology perspective, they would approach yourselves and say, hey, I'd like a machine. I'd like it,
Sure.
this big, because I want to build that size, I guess, structure. And then you would, I guess, go through a learning phase and actually teaching them. How quickly does it actually, before I guess a builder could actually take on from a skill set perspective and learn it? Like, is it super complicated, or is it actually, a couple of hours and you should be right?
No, a couple of hours and you should be almost there. I mean, we normally sort of offer 3 days training, quite intensive training on stuff, but we found most people going sort of halfway through the second day, they're going, okay, we're done. We're confident, and they have been. So that's, I always say to people, as long as you can write a small formula in Excel, that's sort of the knowledge level that you need to run the machine, or have the ability to learn that. But again, it's getting easier and easier, with all the self-learning that we've got going through the machine, and it'll run you through a startup phase, and it'll prompt you through it now. So we're trying to, anyone can stuff something up, right? We do.
Yeah.
But
so there's
making it as hard as possible.
So there's the running it, then there's the setting it up and packing it down and that sort of thing.
Yep.
So I guess it's not a small device.
No.
So what's the setup time in order to actually, put the machine together and assemble on site?
Yeah, and I think I used the example the other day. So we did move one printer we just disassembled it. I can't even say that word now. What is it? Dismantled it. So we dismantled it in one factory, and we literally moved it sort of 30 meters into the other factory. And that sort of took us about 3.5 hours to do that until it was running again. On a site, sure, you do, it looks robust when people see the pictures, but it is all sort of very light gauge, structural sort of honeycomb and things, aluminium. So site's good. You turn up with the truck, you use your Manitou or your 4x4 fork to get it off. What we aim for, and which we normally hit, we'll set the machine up sort of after lunch. It's set up, and then the techies go into their thing and they'll calibrate it, and off it goes. And then in the afternoon, we want to be testing. We want to be doing dry runs, testing the tool path. So then, all going well, you get to go home an hour early, and then the next day you turn up and hopefully you just press the green button. That's the goal. And normally that happens.
Yeah, very good. And it's quite modular in that it packs all the way down. They kind of bolt together. I think you said it's only a couple of spanners to actually put it together.
Yep.
And effectively fits on the back of a custom sled on the back of a truck, yeah?
It does. Yep. So we get all the equipment on the back of a sort of a decent sized truck, and then the truck could disappear. If it's your own truck or you've hired that. That's typically what happens. And as you saw, we've got robots as well. But the advantage of spending the extra time setting a large machine up is you never touch it. It's typically more accurate as opposed to re-referencing something sort of 20 times throughout the print. Swings and roundabouts with everything.
Yeah, but effectively these things are flat packed.
Yep.
They once you've bolted them together, they stand themselves up.
They do.
I guess all hydraulics and that sort of thing,
Yep.
and then it's at that point there's I guess all the science in the machine. You said there's a whole bunch of sensors and that sort of thing, but it's actually able to look at the slab using what's called LiDAR technology. Anyone who's they've heard of radar, but they don't necessarily know LiDAR. It's light. And looking at the speed of light going back and forth, and if it bounced back in a certain amount of time, it traveled a certain amount of distance.
Yep.
So It's using that to go, is your slab level?
How
And
how good is your concreter? I think it says on the screen.
that it does a little bit of a true up and does a self-correcting
Yeah.
phase where it says, well, if the slab's not, I guess, 1,000% perfect
Mm.
over the period of a couple of laps,
We can
we can
self-correct.
we can account for that. Yeah.
Perfect. Yeah, absolutely. And that's the little things to take to take some of the smarts out of it. Otherwise you're trying to calculate stuff. Stop the machine. Whoa, it's going to, where it just knows what it's doing. It knows where it's at. It's got its coordinates. And you're right. It's just like, I suppose you can say it's like a very tight graph paper it's putting down, and it can see the ups and the downs and the bumps and the lumps. And yeah, so, and it'll recommend you with the algorithms we've got in there what to do,
Yeah. So some very smart, nerdy people behind the scenes have made it
Loads
easy
of
to dumb
nerds.
it down.
Yeah, we got them all. You can't talk to them. They can't talk to you. Just ones and zeros. That's all they. I love it.
I guess the long and the short of it, folks, is relatively easy to set up, relatively easy to deploy. Uh, the real effort needs to come into, you got to design for the house to be suitable for this in the first place. That's the first part. And you've got to be, I guess, engaging with your structural engineer who actually understands that. That's probably the two biggest elements that I would see is uh, get your architect to be thinking about what form of prefab technology am I going to use, and there's, I guess, four major pathways, and additive being one of them, and then drill down on that and go, well, we need to engage with, I guess, the suppliers of the material and go, well, what are the parameters and the constraints that we need to consider from our design side? Now,
Yep.
as you said, the parameters and constraints are actually a lot more open than you would in a normal house, because you can do curved
Sure.
walls, you can do patterns in the walls, you can do, I guess, a curvature that kind of goes out, that inside that your duplex is actually a wall that kind of starts low and then starts to overhang itself.
Yeah, it's like an hourglass, isn't it? It's 4 meters high, and it dips in 300 mil in the middle.
Yeah. So
That wasn't an accident.
no, but it's now thinking about, I guess, from an architect's perspective, well, how do I guess,
Sure.
how do I do I guess, take advantage of the technology to actually showcase it, for want of a
Yep.
better word, and then get the engineer to go, yeah, the math behind that says that's going to work.
Yep. Yeah, and at the moment, say it's not in the National Construction Code, but we sort of fall somewhere in between the masonry and the whatever the other code is, the block code type of thing. So somewhere close to a double brick wall's probably the closest analogy, but it's a lot stronger. Although we haven't got the physical footprint of a brick on a layer. But yeah, so we do often consult with other engineering firms and their structural engineer, and we've got all the testing, we've got NADA testing, all the in-house testing, and one of our structural material scientists is a doctor of material science. And he's also a civil and structural engineer as well. So he's got a very, very good background there. Yeah, we've never had a problem so far, because it is so far over clubbed, I suppose, for a typical application. So, and we can show that. And you're right. Now we've had a lot of media and we've got boots on the ground. We've got 1,000 tons out there or more. Never actually worked that out, but yeah, it's, and where I am now, so what do we say? It's been here almost 2 years, and it's nothing's moved a millimeter.
Yeah. And I guess you touched on something there that you kind of brushed over really quick, and
I did.
that's National Construction Code. The certification process and the sign off and what are the complications for anyone wanting to go down this pathway?
Yep.
What are the complications to have it, I guess, approved?
Yeah, not much nowadays. Obviously, we supply performance-based solution on a job-by-job basis, but every single job we do, which has been a lot now, that gets easier and easier. So it's almost a cut and paste. And again, because it's been in the media so much, everyone's sort of aware of that now. We're finding we don't get, I would say, no pushback anymore, from the certifiers. And we'll put the certifier in touch with the engineer who's been with us since day dot as a third party. And he just talks them through it, and they're comfortable. At the end of the day, he's signing off, but sure, the certifier's got to say that we're doing it in accordance with, or I think on a couple of occasions we've done both that elements. We've done the sign off for the structure, and you're right, we're not builders, we're printers. So we'll come in, do the printing like a bricklayer would lay bricks, I suppose, and then bugger off. It's at the moment it's probably easier with a performance-based solution. But yeah, the ex-CEO, the National Construction Code, came down to site when we were printing. So that was very good of him to do that, sort of out of interest and see what we were doing and what it looks like.
Yeah. So I guess in short, I guess the certification process is more an educational element as
Sure.
each certifier kind of comes up to
Yep.
speed on what it's actually capable. Performance type solution, as you said. So he has to make I guess, an arbitrary decision to go,
Yep.
yes, you've put the right, I guess, science behind all of that. And
Sure.
once he's satisfied with that, so but as more and more people become aware, it's more the curiosity of them now than
Yep.
I guess the educational element, because they're kind of becoming very, very familiar with it.
Yeah, they are. Yeah. So and it's good. So and I would say yeah. So we used to get pushback at the start, a lot of sort of snarky questions, I suppose. And I said, man, I'm not here to fight anyone. If ask me the hardest questions, I'll do my best, because we all just want to get to that point. And we're fortunately there now. And there's not much which we haven't done, that we haven't failed at and got better and learned or just, got it right the first time. So we can sort of answer a lot of those questions and tangibly as well with evidence and backup and sort of testing or whatever.
Yeah. Now, I guess this moment in time, I guess the technology is at a point where I think you said before you can do 4 meter high walls,
Yep.
which is really I guess, single story type home
Sure.
at this point in time. You can then, yes, put a floor cassette or something
Yep.
onto that structure and then build above that. But you're typically using the technologies at the second layer at the moment. That's
Correct.
what you've got in your current home.
Yep.
What's the roadmap for 2 stories look like? What are the challenges that need to be overcome for that before that becomes the norm?
Yeah, sure. And that's for a twofold question. At the moment, we'd say we printed this one on site. If we're doing prefab and we're prefabbing it in the factory, then there's no restriction. You know what I mean? So you're placing the bottom story panels. You simply place the top story panels the same way. And I think I told you I was originally going to print this as a second story, but how I was going to do that at that time, I was going to print the upper story panels, concrete panels on the ground floor slab. And then we just get a spider crane in, we lift them up and we place them in place. But eventually it's a family company, VersiClad upstairs. So we used a lightweight composite upper with all their VersiClad roofing as well. So that was, I didn't have to think about it, right? So that was easy for me. But we're also developing a tracked robot model. And that's got its complications because to put a tracked robot up there, you'd have to put a concrete floor in, which everything else is concrete. It's probably not the end of the world. And then you could sort of continue on there with a tracked robot upstairs. So we did originally design this current printer to go up to 2 stories, but we got busy again. You know what I mean? What was the market? We had enough in the single story market at that stage, and we still do. But you're right, there's complications when you start doubling the height of machinery and you've got the wind loads, you've got the dynamics, there's other things going on. You've got to slow the machine down to half speed. You're pumping through a hose a lot further. You've got more friction. It's not a straightforward.
No, but
doable, right?
That's right. It's not able to be overcome. It's just about thinking about it differently, like you said.
Yeah, and we've been busy. We're just, no spare seconds in a day, so you just got to pick your battle, right?
So you can still use the same machine and print on the ground floor and then lift it up. So you can get that second story up there.
Correct.
So it's not a no, don't do it. It's just, hey, I'm going to do it differently.
Yep.
Right.
And that's what they do in Europe typically. That's their methodology.
Yeah. And I'm sure at some point when you do get some time and you're not doing 100-hour weeks, then I guess the actual, extra effort in actually engineering that second layer, as a single type print, I'm sure will be in the pipeline.
Yeah, of course. Yeah, and it's possible now. So we designed it as an add-on to this machine, but it was just, we had other higher value targets, I suppose, that we wanted to attack.
Yeah.
And then if we're printing everything as a prefab in the factory, then that goes away again.
Yeah. And look, I was fortunate enough to be in the workshop and see some of the things that are in the pipeline that you're working on with regards to different model machines. And I won't give away any of your IP there. You feel free if you want to do that. But what I can say is that current machinery and the current models there are a fit for purpose type product, but there are other purposes, and you're building other solutions to try and meet those as well. And I think the roadmap for 3D printing, I think, is very robust.
Yeah, oh, absolutely. Yes, and we've learned along the way. I mean, these our current generation 4 printers, they're perfect. You know, they're perfect. Actually, they're world's best print quality, so they're very good. And we've got so much demand from overseas to start selling them and exporting them. So we're gearing up to do that more so. But yeah, you're right. The new printers that are coming are sort of exotic materials and all the rest of it, and huge, what was unobtainable, I suppose, 5 years ago, sort of dimensions and reaches and things. So
Yeah,
it's a really cool technology.
Yeah, and folks, even if you're not wanting to print a house, I was there the other day when you said, "Well, there's our plastic print head that actually to go on side of that." So if you're one of those nerds who just print giant things on your desktop printer at home, one of these bad boys will print you all sorts of things.
It'll dwarf you. That thing at a maximum capacity will put at 60 kilos per hour. 60 kilos. You know, which is way overclubbed again.
Yeah.
But they're like, what do you want? The biggest.
What do you got?
So I think we're printing that one that you saw there it was for a roadway authority, some stuff for them. And we're probably only printing at 15 kilos per hour, you know, so.
Yeah. So, hey, been a pleasure, getting to know you, seeing the factory, seeing the real world element. There's been some visuals relaying what we're talking about as we go, but if anyone was thinking about trying to go down the pathway of either A, buying a machine, or B, hey, I'm wanting to actually print a home, what would be, I guess, the primary message that you want to have them take away?
I think I said at the start, always test the water with both feet, dive in, you know, you want to get one shot at it. You know, it's so cool and to stretch, you know, I mean, we've got the engineering sorted, we've got the materials, we've got the machinery. That's a lock, that's solid, you know what I mean? So I suppose you just got to open your mind to it. And you get those people that never will. You get the first adopters, early adopters, which always will. But I think we're somewhere in between the two of them at the moment. So stretch, come here, have a look at this. You know, we've stretched things. This might be a house when 10 years time or 20 years ago, what were they thinking? You know, but then it comes back, right? It's like velvet wallpaper.
Yeah.
But
I don't think that ever came back. But
you haven't been in my bedroom.
I'm not sure if that was an invitation, Nick, but the answer is no. Thank you anyway. Mate, it's been an absolute pleasure. Thank you very much for this. Folks, if you have enjoyed this show, we are always interviewing, industry experts like Nick, not only on our YouTube channel, but also in our live events that we run all the way around the country. We run them in Brisbane, Sydney, Melbourne, Adelaide, and Perth. Pretty much every weekend of the year, we're running an event, 55 events per year. Make sure that you actually come along to those. We also have members of our community sharing real deals. So you get to see the good, the bad, and the ugly of a project. Maybe we can convince Nick to get, one of his clients to actually share a real deal on his 3D printing.
I think I'm the only ugly in here. So.
Yes. So thank you very much, folks. We'll see you on the other side. Bye for now.